Okay, now that you've developed the algorithm for Caesar cipher, it's time to turn it into code. We've started here with the Caesar cipher class, which has an encrypt method which takes the input to encrypt and an integer for the key to use to encrypt it. I've written here the comments with the pseudocode that we just developed in our algorithm, and I've gone ahead and written the first 2 lines of code. The first step is to make a new string builder with the input and call it encrypted, and the second is to write down the alphabet, which is a string. The next thing is to compute the shifted alphabet, so we're going to make a string, shifted alphabet. And remember, we saw in previous videos that we can use substring to do this. Alphabet.substring key concatenated with, that's what plus means for strings, alphabet.substring 0, key. That will slice the alphabet up into 2 pieces and concatenate them back together to give us the shifted alphabet that we want. Now we want to count from 0 to being less than the length of encrypted, and we want to call each number that we count I. So this is going to be a counting for loop for int I equals 0. I is less than encrypted.length, the length of encrypted, I++. And what do we want to do? Well, we want to look at the ith character and call it curchar. Curchar equals encrypted dot char at I. Then we want to find the index of curchar in the alphabet. Int idx, we said over here call it idx, equals alphabet dot index of curchar. And then we want to see if that's in the alphabet. As you've seen before, index of will return -1 if something is not there, and some other number if it is. So it would not be there if idx is index or is -1. We want not equal to -1 to mean it is there. Now we want the idx char of shifted alphabet, and we want to call that new char. Equals shifted alphabet dot char at idx. And now I want to replace the ith character of encrypted with new char. So encrypted set char at, and then I want the ith character to be new char. That's everything I want to do inside of that if. Otherwise, do nothing. I don't need to write an else if I don't want to do anything otherwise. This curly brace closes my counting for loop. And at the end here, I said I want my answer, so I want to return something, to be the string inside of encrypted. So encrypted.toString. I'm going to compile that. It says no syntax errors. And I've written here already this method testCaesar, which is going to make a new file resource, so it'll prompt us for a file, read it all in as a string, encrypt it. It will print out the encrypted message, and then it will also decrypt it and print out the decrypted message, because if we just saw a jumble of random characters, we wouldn't really be able to tell if we did it right, but being able to tell that we got the original back makes us more confident that what we did was correct. So I'm going to go over here to BlueJ. I'm going to say new Caesar cipher. I'm going to say testCaesar, and it's going to prompt me for a file, and I have here this message in a file called message1.txt that says free cake in the conference room. Maybe I want to send this to Robert without Owen seeing it and being able to get all the cake, and so I'm going to choose message1.txt, and we can see the encrypted message here, WIVV, etc., etc. It's been made more difficult to read, and then we can see down here where it decrypted it correctly. So I'd be a little more confident in this. I'd want to go through and check by hand that this actually came out with the correct key before I'd be completely certain that this test case worked correctly.